Çok teşekkür ederim Sayın.
Thank you very much, Mr. Chairman. We had the chance to listen to three. This morning I was asking to myself, how dare I was speaking in the same session with three very valuable professors. After Mr. Dost's presentation, I don't know how much he would be willing to my presentation, because before our clinician professors started making their presentations, I was making to lay down the basis. Only the glutamate cycle has been explained anyway. Synaptic dysfunction and synaptic dysfunction-oriented intracellular mechanism changes shall be tackled in this presentation of mine. As we all know, stress is the beginning of this process. Organism goes through a series of changes. Cardiovascular risks, carbohydrate mechanism changes follow this process, and then as the depression and as the stress becomes more chronic and turns into depression, neurodegeneration, neuroinflammation, and concepts like those are also involved in the process. But in this presentation, I'm going to talk about the changes in the intracellular mechanisms, and I will talk about mechanisms related to mDNA. I will talk about neurotrophic factors, and then I will try to conclude my message. Since 1950s, monoamine hypothesis is in questions. After the involvement of the other neurotransmitters, depression neurobiology has started to seek new options for itself. One of those neurotransmitters has become very important in the last decade, and this is obviously glutamate. Neurotransmitter functions. In order to understand those, we're using synaptic transmissions. Pre- and post-synaptic transmission neurons are trying to affect certain processes, but when we talk about glutamatergic synapse, we see something different because it has a triple structure. As far as I know, Mr. Dost also talked about it. The glial cells make up a very important part of this process because glutamate, which is in the synaptic space, is being reuptaken and then it is presented to presynaptic cell, and this compound plays a very important role in this. And different changes are seen, like the volume reduction and atrophies in dendritic structures. And today we know that this has something to do with glutamatergic system, and the process goes on with a new structuring due to those changes. Therefore, in the clinic, different findings, imaging techniques, etc., show us the changes in this area. So this triple synaptic structure, let's have a look at this triple structure. In the presynaptic neuron, the synapse formation capacity goes down, the number of synapses go down, the synthesized glutamate is taken into the vesicles with the vesicular transporter, and this transporter's activity also goes down, and glutamate release increases. In the postsynaptic neuron, especially branching is reduced. In neurotrophic support, neuron survival and strength are provided by the trophic support, and this trophic support goes down, and excitatory amino acid pumps are also increased. Biliary cells are also involved in this process. Glutamate uptake goes down, and the trophic support also goes down as a result of this. Glutamate is parallel to a monoaminergic efficacy decrease and trophic support decrease. In parallel to this, different from healthy people, there is less synapse and less strong synaptic connection. So glutamate's most important supporter is neurotrophic factors. As we all know very well, neurotrophic factors are actually depending on the development and the branching of the neuron cells. They are very much related to those. DNF has been one of the most important worked on in depression. More dendritic branching is formed as a result of this during cell growth. Therefore, more synapse formation capacity can be provided by the neuron. And on the other hand, together with the release of glutamate, changes in postsynaptic area takes place, and intracellular calcium amount is increased, and NMDA receptor initiating this activation process is then affected by the alpha receptors, and the receptors who are kept silent in the cell is taken up to the surface, or on the contrary, or we see the contrary. I mean, the activation starting with the NMDA receptors have a less activation, and the alpha receptors on the surface start being silent again, and they are taken within the cell, which means the number of receptors move a lot, change a lot. I said that neurotrophic factors is the most important auxiliary to glutamate. Neurotrophic factors use their own specific receptors to show their effects. They are important endogenous substances. BDNF binds to TRKB receptors, and BDNF binding to TRKB receptors activates 3 different pathways in the cell. In terms of, since we're talking about new approaches to treatment only, I'm going to talk about 2 proteins which are effective in this pathway. One of those is ACT, the other one is ERK, AKT, and ERK. Transcription factors, therefore, the survival of the cell and remodeling of the cell are determined by this very critical step. This change doesn't only take place in the neurons, but the supporter, the auxiliary of neuron, glial cells also are involved in the process, because in glial cells, synaptic remodeling takes place, and the neurotransmitter level, as Dostbey mentioned in his speech, changes glutamine to glutamate. Therefore, they are also accompanying this very important process. If there is a defect in the glia, then the effect causes neurotoxicity, and pro-inflammatory processes accompany this course. And dendritic atrophies in the neuron take place. The branches disconnect from one another, and if this damage is not repaired, the problem increases. Therefore, synaptic connections are weakened. One of the most important components is cytokine release. Yesterday, we had the chance to listen to 2 wonderful presentations about the cytokine release. Dr. Brian Leonard and Dr. Müller have given wonderful speeches on that. Both depression and schizophrenia neurobiology and the increase of pro-inflammatory cytokines were discussed, and the future hypothesis would be based on this concept, they said, so I'm not going to go into its details. Under the light of all these data, experimental studies and the human findings show that the changes on glutamate level and the accompanying monoaminergical transmission and the defects in the glia cells and the trophic factor reductions and the new take us to a new structuring in the neurons, and with the right treatment strategy, this situation can be recovered. Why did I talk about those? Because in 2010, a very important trial has been published. Something we know as a general anesthetic material, but which actually is an NMDR antagonist, ketamine, and its use in the depressive cases which are resistant to treatment, and they were infused to those patients, and an antidepressant efficacy started in hours as a result of this. So after the processes which are really which were really long. Now we're speaking about hours only. So different experimental trials have been conducted, and mechanism-oriented changes within the cells were tried to be understood to understand those intracellular changes. There is this mTOR protein, and the new drug molecules have an effect on this mechanism too. I don't know if I have to remind you of NMDA receptor among the neurotransmitter receptors. This receptor has the highest binding area, and ketamine has a binding area right below the ion channel. Therefore, the cell flow is very much controlled by this component. So glutamate and NMDA will be very important parts of this process, and neurotrophic factors will give the required support. But while getting that support, ACT and ERK proteins, their phosphorylation and their mTOR level changes will be the other two parameters to take into account to evaluate the efficacy of those drugs. When we use the ketamine, NMDA receptors are blocked, calcium that comes into the cell and the mechanisms which are affiliated to that are controlled. The other ionotropic glutamate receptors, AMPA receptor traffic is also controlled by this process. If neurotrophic factors are added on top of this, if BDNF is enough and if it is binding to TRKB receptors, then both ERK and ACT processes function properly, and mTOR formation enables the neuron to carry out a proper communication. Successful antidepressant treatments are targeting this mechanism mainly today. So ACT, ERK, and mTOR trio should be evaluated. When we look at the experimental studies, we see that in rats where we create chronic stress, dendritic atrophies are observed. Dendrites lose their branches, lose their ability to connect. And the reason why the trial I've talked about is so exciting is that this remodeling process benefits from the role of ketamine, because ketamine can enable normal dendritic resistance and effect in a very short period of time. Therefore, the synaptic links are stronger. So what is the difference between this and the other treatments that we're using today? For example, SSRIs have an effect on receptors which are bound to G protein mainly. Therefore, their intracellular mechanisms act slower, and neurotrophic factor transcriptions require a longer term, but NMRD receptors might initiate this effect and it continues with AMPA, but this effect takes longer. Therefore, trophic support is increased and a strong efficacy and a fast efficacy can be formed. This scenario has another player, GSK3. In the neurobiology of schizophrenia, it was found to be very important, but recently it has been revealed to be very important for depression as well. What does GSK do? As long as it is in low concentrations, axonal growth and neurotransmitter release are kept at the desired levels. GSK levels, when they increase in the presynaptic part, axonal growth and dysfunctions about the neurotransmitter releases take place, and we do not want this. Similar effects can take place in the postsynaptic neuron as well. If we look at the postsynaptic neuron, low GSK levels affects the receptor internalization traffic. AMPA is very important for depression, and the transmission power are kept at a certain control. However, GSK 3 level, if it increases in the post-synaptic level, we see many impairments. Therefore, GSK3 activity and keeping it at a certain level should be added to the triple effect, which I've just talked about. In terms of those changes, GSK3 receptors play a very important role. If we are to put this in within the mechanism I've just talked about, there is a glutamate release, and there are those silent receptors in the cell. Chronic stress and depression increases GSK efficacy. The receptor traffic is impaired, and since the support of glia goes down, the glutamate level in the synaptic space cannot be controlled. And drugs like ketapine provide the drug traffic. They inhibit GSK3. Therefore, ACT-ERG and mTOR mechanism like trophic support components are benefiting from this. What are the new molecules? These are new molecules which I would like to show you. Of course, NMDA receptors, all binding areas make up a target. Many GSK3 receptor drugs are being worked on. Only ionotropic glutamate receptors, I talked about those, but pre- and post-synaptic localization is provided by metatropic glutamate category. And finally, I would like to talk about the transporters. In this triple structure, the excitator amino acid carriers function normally. They take glutamate and turn it into glycemine, and when there is depression, the effect of those pumps is very low. Therefore, excitator amino acid transporter inhibiting drugs make up another very important group. So what to prefer, which way to follow, is now very much like an adventure. But as it was discussed in the panel yesterday, glutaminergic receptors, excitator amino acid carriers, transporters, and TRK and GSK seem to be the drug molecules of the future. I would like to invite you to our Congress, which will take place in April. Thank you very much for your patience.